Okay, dear students, welcome. So far, we have studied about the frequency modulation, the graphical representation, and analytical treatment, that is, the derivation for the voltage of the frequency modulation, and also we have studied how this frequency modulated wave is generated using FET reactance modulator. Today we shall discuss about the communication of frequency modulated wave. For the communication you need two devices. One device which communicates or radiates the message signal, and another device which receives the message signal. At the point where we transmit the signal, the device is called transmitter, and at the point where the signal is received, the device is called receiver. Therefore, today now we shall discuss about frequency modulated wave transmitter. This will explain how the frequency modulated wave is transmitted. How the frequency modulated wave is transmitted into the space. You have only a functional block diagram. That is, to transmit the frequency modulated wave, first you have to generate the frequency modulated wave, and you need two signals. One, our message signal, that is voice or speech or any information to be sent, that is message signal. And since the message signal is very low frequency, cannot be transmitted, you need mixing up of that signal with high frequency signal called radio frequency signal or carrier signal. And the mixing up of these two processes must be such that the frequency modulated wave is generated. And this wave is then applied to the conductor known as antenna. This antenna will radiate this signal into space as electromagnetic radiation. This electromagnetic radiation travels with speed of light because the resultant wave is a very high frequency, that is radio frequency. They almost travels with the speed of light. Now we shall discuss about the block diagram and its functional block diagram. See, this is the block diagram for frequency modulated wave transmission. This is a complete block diagram. See this complete block diagram. Okay, and I will explain one by one what this block diagram does. The function of each block diagram is mentioned in the box. AF means audio frequency, where the frequency ranging from 20 Hz to 20 kHz, that is our voice and music or any information, that is called message signal, which is to be transmitted. Okay, now see, the next one is reactance modulator. We have already studied the FET reactance modulator, where the output of the FET reactance modulator is a capacitive reactance or inductive reactance. This capacitive reactance or inductive reactance is directly proportional to the amplitude of the message signal, and therefore it is frequency modulated wave. The next one is oscillator. Oscillator is an electronic device which is usually an amplifier circuit with positive feedback, and it produces oscillations, that is signals of frequency. Next stage is buffer amplifier. I will explain what it does. Next, limiter. Let's come to this. frequency multiplier, and after that RF amplifier. Amplifier is an electronic circuit which amplifies or strengthens the input signal at the output. Small signal is amplified at the output, that is called amplifier. The name RF is called, this amplifies only the high frequency signal, that is radio frequency signal. Here the name AF is also an amplifier, where this amplifier amplifies the low frequency signal, that is from 20 Hz to 20 kHz is a low frequency which is audible. Therefore that amplifier is simply named as audio frequency amplifier, and high frequency amplifier is simply named as RF amplifier, radio frequency amplifier. Now let us discuss about the function of each diagram, each block diagram. First, consider this modulating signal. This modulating signal is our voice signal, where the EM, the signal of modulating, is represented as capital EM into sine of omega mt, where omega m is equal to 2 pi FM. FM is called modulating frequency, that is our voice signal frequency or any message signal frequency, and FM ranges from 20 Hz to 20 kHz. It is an audible, and this is the message signal to be sent. Therefore this signal, modulating signal, is also called message signal. Now this message signal is first applied to pre-emphasis. This is because when I speak, this produces waves of different frequencies and different amplitudes. Now I am speaking. When you see this wave through an oscilloscope, oscilloscope is a device which will display the waveform. So the electrical waveform, when I speak, it may be like this. That is, it is having different frequencies and different amplitudes. This maximum amplitude has low frequency, and the minimum amplitude has less frequency. And this type of signal cannot be applied to the electrical circuit. Therefore, what we have to do is, we have to increase the small amplitude into large amplitude with respect to this low frequency amplitude. That is, pre-emphasis is an electronic circuit which increases the amplitude of high frequency signal with respect to the amplitude of low frequency signal, so that the resultant signal, message signal, can be applied to any electrical circuit for proper working. So this is called pre-emphasis circuit. It is usually high pass filter, that is, high frequency is passed at the output, and it has high amplitude compared to low frequency signal. Low frequency signal already has high amplitude. High frequency signal has low amplitude. When it is applied to a high pass filter, high frequency will have more amplitude. I will explain it later why pre-emphasis is needed. And you must be noted that at this transmitting station, first pre-emphasis is needed. At the receiver station, opposite, that is de-emphasis is needed. Here we are discussing only transmitter. Therefore, I will explain only preamplifier. So preamplifier is an electronic circuit which increases the amplitude of high frequency with respect to the amplitude of low frequency, and it is then amplified by an amplifier known as audio frequency amplifier, because this is our message signal. The message signal can be heard. It is ranging from 20 to 20 kHz. It is audible. Therefore, the amplification of that signal is called audio frequency amplifier. This will raise our message signal to the required level. Now, for frequency modulation, you know that this message signal must be mixed with the carrier frequency. Okay, now this oscillator, you know what is oscillator? Usually it is a parallel combination of L and C tank circuit with an amplifier circuit with a positive feedback. This constitutes an oscillator. Electronic circuit, you have only block diagram explanation, functional explanation, only function, not circuit and its working conditions. So this oscillator consists of amplifier circuit with positive feedback and the tank circuit. Tank circuit is the parallel combination of L and C, where the frequency of this tank circuit is given by F is equal to 1 over 2 pi root LC. This is the frequency. Now, this is the FET reactance modulator. We have already discussed it. FET reactance modulator. How the FET reactance modulator exists? See, this is the, I will write here, FET reactance modulator. We have already studied. The FET first it consists of FET. Arrow mark outside shows N channel FET. N channel. This is the source, this is the gate, this is the drain. And drain must be applied to a positive voltage DC source. I will call this as VDD. Voltage applied to drain. That is DC voltage. To activate the transistor, DC voltage is necessary. Now, I will connect a capacitor between the drain and the gate. And I will connect a resistor between the gate and the source, so that the output of this is either capacitive reactance or inductive reactance, depending upon the component you have connected here. We have studied capacitive reactance of FET reactance modulator because capacitor is connected, where the output between these 2 points is X is equal to 1 over omega C equivalent, and we have derived an expression for C equivalent is equal to GM into RC. However, remind that the output of this is capacitive reactance, and this message signal is applied between gate and the source. This is our message signal. When message signal, that is voltage, is applied here, that acts as a gate source voltage. Gate source voltage is our message signal. This produces drain current ID. Then this ID is a function of the capacitive reactance obtained at the output. Therefore, capacitive reactance XC depends upon the drain current. This drain current, depending upon the message signal applied between gate and source, we have already studied. Only functional block diagram. Here the message signal is applied here to the gate source of FET reactance modulator. Output will be capacitive reactance XC. I will call this as XC. So this capacitive reactance X is directly proposed to the message signal, that is the amplitude of the message signal. X is directly proposed to the amplitude of message signal. And what is Xc? It is 1 over omega C equivalent. And we know that C equivalent derivation is GM R into C. GM is unit, that is conductance, R is resistance, unit get cancelled, ohm and mho are reciprocal to each other, C is farad, therefore GM or C is a capacitive reactance. It has a unit of capacitance, therefore it is capacitive reactance. When this capacitive reactance, output of reactance tube, is connected in parallel with this, and what is this real frequency, which is F is equal to 1 over 2 pi root LC. Now this C equivalent output of this reactance is connected here. It is in parallel with this original C. Therefore the net resultant is C plus C equivalent. Now the frequency F becomes 1 over 2 pi root of L into C plus C equivalent. So this is the frequency obtained from the oscillator, because the oscillator consists of this tank circuit, for which the output capacitive reactance from reactance modulator is applied in parallel. Net capacitive becomes C plus C equivalent. Therefore F changes, frequency of this oscillator changes. How it changes? Because of C equivalent. How C equivalent changes? The C equivalent changes according to ID. How ID changes? It changes according to message signal. Thus message signal is applied here, reactance tube modulator is present here, and it is applied to the oscillator, and finally output of the oscillator is frequency modulated wave. You get a frequency modulated wave from the oscillator. Now it is applied to the buffer amplifier. Buffer amplifier is usually a common collector amplifier, because transistor is connected in three configuration: common base configuration, common emitter configuration, and common collector configuration. In common collector configuration, output voltage is equal to input voltage. There is no amplification. In common collector amplifier, there is no amplification. But only thing is, the output impedance becomes low. When the output impedance becomes low, whatever the signal from the oscillator is entirely passes through that low resistance path and is fed back to the next circuit. That means buffer does not alter the output of this to the next stage. Therefore, it is simply isolate between the previous and the next one stages. So buffer amplifier is a common collector amplifier. It isolates the two stages, previous one and after one. Now after passing through this buffer amplifier, it is fed to the limiter, the frequency modulated wave FM, where the frequency of the frequency modulated wave is, you know, that Fc plus or minus delta F, where delta F is called carrier deviation. It depends upon the amplitude of our message signal. You have already studied. So Fc is normal carrier frequency, which is produced by the tank circuit of oscillator, and plus or minus delta F is the carrier deviation, that is deviation from the frequency of tank circuit. This deviation depends upon the reactance of the modulator, which in turn depends upon the input message signal. Therefore, this is a frequency modulated wave. Here, limiter means it will limit the amplitudes of the frequency modulated wave, because if amplitudes are very large, the noise may be included. When the noise is included, the transmission is very poor. You will hear other sound than the original sound if noise is present. Therefore, we have to limit the higher amplitude to the required level. That is done by the electronic circuit known as limiter. And of course, the amplitude is limited, but the frequency deviation may be very small, and the carrier frequency Fc may be very small in terms of megahertz, and this frequency cannot be transmitted to for a long distance, and it cannot be transmitted as electromagnetic radiation. They may not travel with frequency, light frequency is very large. Therefore, you have to increase this carrier frequency Fc as well as this carrier deviation delta F almost equal to light frequency. That means you need to multiply this. Therefore, there is an electronic device or electronic circuit which is known as frequency multiplier, which multiplies the incoming frequency. Suppose if it multiplies n times, both n and carrier deviation gets multiplied. Output of this is now NFC plus or minus n delta F. This n times Fc plus or minus n times delta F is a very high frequency called radio frequency, and this radio frequency is amplified by radio frequency amplifier. That is, the amplitude increases to the required level. The small amplitude voltage cannot be transmitted because The antenna requires power to transmit it. If voltage is very small, power is very small. Therefore, not to get more power to the antenna, you need high voltage. Therefore, RF amplifier will amplify this high frequency, radio frequency. It is then fed to this antenna. It is just a conductor or aerial or antenna, whatever it may be. Then this antenna produces electromagnetic field when this RF current passes through it. ಯಾವಾಗ ಆರ್ ಎಫ್ ಕರೆಂಟ್ ಇದು ಮೂಲಕ ಹೋಗುತ್ತೋ ಇದು ಕಂಡಕ್ಟರಿಂದ conductor will produce magnetic field when current passes through it. Therefore, this electric current and the magnetic field produced, they are perpendicular to each other, and electromagnetic radiation is obtained from this antenna. So, the electric field perpendicular to the magnetic field and electromagnetic radiation is perpendicular to these two. One is x-axis, another is y-axis, another is z-axis. So, this frequency modulated wave is transmitted into space as electromagnetic radiation, and therefore it can travel through any longer distance. And you can have another device any point on the earth so that you can receive this electromagnetic radiation and again you reproduce it back our message signal there. That is our that device is called receiver. We shall discuss it later. You come here. This reactance modulator is FET reactance. See here. For that, drain should be connected to a positive DC voltage. Okay. How do you get this DC voltage? Very simple. See, this output of the limiter. A part of this is taken and applied to the mixer, and you can create some frequency, say f0 locally. It is an oscillator called crystal oscillator. This produces oscillations. I will call the frequency of oscillation as f0, whereas the frequency of this limiter is fc, carrier frequency. Why we use crystal oscillator? There are different types of oscillators. Colpitts oscillator, Hartley oscillators, RC phase shift oscillator, Wien bridge oscillator, and etc. etc. In this crystal oscillator, the oscillations are produced by the crystal placed between the two plates. You don't have circuit, okay? Just know the function. Crystal oscillator is an electronic circuit which produces stable frequency. Other oscillator may not produce stable frequency. Stable frequency means, for example, if it produces 100 megahertz, this 100 megahertz is fixed for all on time of this. ಎಷ್ಟೇ ಹೊತ್ತು ಆನ್ ಆಗಿದ್ರು 100 ಮೆಗಾಹರ್ಟ್ಸೇ ಇರುತ್ತೆ. ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಬೇರೆ ಆಸಿಲೇಟರ್ ಆದರೆ ಸ್ವಲ್ಪ ಸ್ಲೈಟಾಗಿ ಚೇಂಜ್ ಆಗೋಗುತ್ತೆ. Therefore, crystal oscillator produces an output frequency of f0 which is very stable, and another output frequency fc is taken from the limiter. These two frequencies are applied as input to the circuit known as mixer. Mixer is an electronic circuit which mixes up the two input frequencies, and it produces the mixing frequency at the output. How they mix us? One frequency is f0 plus fc, sum of the two, and another output may be f0 minus fc, difference of these two. That is one low frequency f0 minus fc, or if fc is greater than f0, I can write like this: fc minus f0, low frequency, another fc plus f0. It is called beat frequency. The mixer produces usually the beat frequency of the two input, that is fc plus or minus f0. In this output, fc plus f0 is removed to the ground by a capacitor, because capacitor allows signal of frequency. If it is grounded, that will this high frequency bypass to ground, and only the output of this mixer consists of the frequency fc minus f0. the difference of the two input frequencies. This frequency is called intermediate frequency. All over world, if you have FM transmitter, this intermediate frequency is fixed, that is 10.7 megahertz. Whatever may be the message signal, whatever may be the frequency of the frequency modulated signal, but the intermediate frequency is fixed to 10.7 megahertz. This is for FM transmitter. And for AM transmitter, it is 455 kilohertz standard all over world. Intermediate frequency of a transmitter in the case of AM is 455 kilohertz. Same the intermediate frequency of the transmitter in FM transmission, it is fixed as 10.7 megahertz for all FM transmitter. Okay, whatever it may be. And this signal frequency Fc minus F0 is applied to the discriminator. Discriminator is usually, it changes the frequency into voltage. And this discriminator changes this difference in frequency into corresponding voltage. AC voltage is converted, this is AC signal. AC voltage is converted into DC voltage. After passing through the low pass filter, low frequency is allowed at the output, high frequency is removed, and that low frequency is a DC, low frequency voltage is a DC voltage. This DC voltage is fed to the drain point of this reactance modulator. See, this is plus DC voltage, okay? This plus DC voltages are obtained from this process. What is low pass? How it converts? See the graph. I will not explain the circuit. Simply I will write the graph. The frequency against the voltage, when you plot a graph for low frequency, low pass filter, this output voltage is allowed only for the lower frequency. After high frequency, output falls to 0. Since this is a constant voltage, this is called DC voltage. Therefore, output of low pass filter is a DC voltage. It is then fed to the drain of the FET reactance tube modulator. Then FET reactance tube modulator will work in proper condition. Then it produces the output, a capacitive reactance. This depends upon the message signal, and it is then fed to the tank circuit. Therefore, tank circuit frequency changes according to the amplitude of the message signal, that is our FM, that is frequency modulated wave. This is how you have to transmit the frequency modulated wave. You have only functional block diagram. Each block diagram has its own circuit, own function. You may be studying in the higher class. You have to write the required block diagram, and you have to say only the function. AF amplifier, it amplifies the audio frequency signal. Reactance modulator, it produces the capacitive or inductive reactance at the output, which depends upon the input applied to it. Like that. Buffer amplifier, it is a common collector amplifier. It feeds the entire voltage of the previous to the next stage, or simply we can say that it isolates the previous one from the next one. Frequency multiplier, it multiplies the frequency. Even if this FC coming from this frequency modulated wave is high frequency, if it is not sufficiently high, you have to multiply it. That is done by the frequency multiplier. After frequency multiplier, since it is a very high frequency known as radio frequency, and it is amplified by RF, that is our radio frequency, then fed to the antenna. The FM wave is radiate into space as electromagnetic radiation. Now you can receive that signal anywhere on the earth using another device known as receiver. We will discuss it later. Thank you.